In this video, we'll be talking about the independent samples t-test. To use an independent samples t-test, we need two variables. One variable is binary in that it only has two categories. The other variable is typically a continuous level variable, interval or ratio level. So let's propose a research question. In this research question, are men more punitive than women? So by the way we asked the question, let's make a hypothesis, and let's make it a one-tailed hypothesis. With an independent samples t-test, you can make either a two-tailed hypothesis or a one-tailed hypothesis. So let's state men are generally more punitive than women. And we can test this hypothesis with two variables we have in this data set. So the first variable is gender. So notice women or females are coded as 1 and males as 2. And then we have a variable towards the bottom here called punish. And it's called the Thurstone punishment of criminal scale. Notice that there's no coding here, and that each variable stands for what it is. Technically, the Thurstone punishment of criminal scale is a metric ordinal scale. So what happens is people are asked a bunch of questions at the ordinal level about punishment, and let's say 10 questions, and then their answers are all added up. So the idea is all of those ordinal questions added up give you greater degrees of variability and more, so the variable looks more like an interval variable than it does an ordinal variable. So technically it's not an interval variable, but because it's a metric ordinal variable, we treat it like it's an interval variable. Notice, or if you recall from earlier in the course when we talked about different levels of measurement and the error, if you treat one level of measurement like this, there's this much degree of error, and so there's a small degree of error in treating metric ordinal like interval, but it's done frequently enough in the literature for us to use a metric ordinal variable as a dependent variable for an independent samples t-test, or for any t-test or ANOVA or regression or anything else that requires a continuous level measurement. So let's look at each of these variables by themselves. So let's conduct a frequency distribution analysis. So I'm going to look at my two variables, gender, and then Thurstone punishment criminal scale. So for this I want mean, median, and mode, mainly for the Thurstone scale, not necessarily for gender. Skewness and kurtosis, again for the Thurstone scale, because I'm going to treat it like an interval and use it for an independent samples t-test, so it needs to fit the assumptions otherwise of the independent samples t-test. And I'm going to look at the standard deviation, continue, charts, histogram with a normal curve overlay, continue. I want the frequency distribution tables displayed. Click OK. So the first thing I'm looking at is the gender of the respondent. The most common category is 1. Women were coded as 1, men were coded as 2. And then when we look at the Thurstone punishment of criminal scale, notice that the average is 60, the median 62, and the mode 74. So it looks like we have a somewhat negatively skewed distribution looking at the means relationship to the median. And then when I go down to the skewness variable, I see that it's negative 0.491. So that it's somewhat negatively skewed. And I look at the kurtosis, and it's somewhat flat, right, with a negative 0.192 as a score. Notice that the skewness and kurtosis values are within that positive negative 1 range. And so even though I might not have an exact normal distribution, I can treat it as such because our skewness values and kurtosis values are within that range of tolerance, that positive negative 1 value. So I'm going to scroll down and look at women compose 52% of the sample, men 48%, and there's my frequency distribution table for the punishment scale. And so notice how many values there are, and here's the histogram for it. And so notice that it's not exactly normal. Clearly it's not exactly normal. There's a peak here in the low 70s, but again, it's within that normal it's within the tolerance level of that +1, -1 for skewness and kurtosis. So we're going to treat this like it's a normally distributed variable. So next I want to see if there's differences between the groups, between men and women, on their level of punishment. So I'm hypothesizing that men are more punitive than women. So if men had a higher average than women, that would support that. So I'm going to go to graph, and I'm going to go to legacy dialogues and choose bar graph. Simple is what I want, so make sure that it's outlined in the heavy dark line. Click define. So I'm going to first search for my gender. I'm going to make that my category axis, so I'm going to have a bar for each category of the gender, which is only 2 bars. And then I'm going to choose thirst tone punishment, and I want to move it here, so I want to choose other statistic, then I can move it here. So I'm just going to choose the mean, and that's what I want. So this time I'm going to go to options, and I want to display error bars, and I want standard error multiplier 2.0. So I want to see the 2 standard error higher and lower boundaries for each category. So I'm going to click continue and click OK. So notice that the 2 bars are roughly similar, so I'm going to click on it and show the data labels to get the exact mean values here. Click close. Click close. So notice that there's not much difference at all. 60.53 for women and 60.81 for men. So in reality there is a difference, but we can see that there's clearly only very little difference here. So I want to see if, but notice the standard errors are very tightly clustered together, and so what this means is there's very little variation. So on the one hand, my measures of central tendency are very close to one another, and the standard errors are very small for each group. So there could be a significant difference between these two. So only a hypothesis test with a t-test would show us that. So the next thing I want to see is an important assumption for the t-test is that the variability for each group is roughly the same. So I need to see what the variability looks like for each group. So I could do that just by looking at the standard deviations for each group, or I could do that visually with a box plot. So if I want to see that with a box plot, I go to legacy dialogues, choose box plot, simple, define, and do the same thing here. I'm going to move gender into the category axis, so I have 2 bars, one for men and one for women, and I choose my variable, which is the thirst tone punishment scale, and just click OK. So notice here that the box plots aren't too dissimilar. So the boxes, the middle boxes, are roughly the same. Maybe the males is slightly more condensed, but not much. But the whiskers for the women are slightly longer, but not much longer. And so when I look at these two, it doesn't give me a lot of cause for concern that the 2 variabilities are too different. They're really close. They're fairly similar to one another. But the only way to truly test this is when we generate our t-test. There would be a test to see if the variances between the 2 groups are roughly the same. So knowing that men have a slightly higher mean level of punitiveness and that their variances are somewhat similar, with women having slightly more variability as indicated by this whisker here. Now it's time to run the t-test. So I think I'm going to meet the assumption of equality of variances. So the next thing I do is I go to Analyze, and I go to Compare Means, and I choose Independent Samples t-test. I click that, and I'm presented with a dialog box. And so what I need to do is I need to move my gender variable, which is my grouping variable, my independent variable. Choose that, and I move it here. So notice the question marks. It's asking me to define the groups. Remember that women were coded as 1, men were coded as 2. So I go to define groups, and I define the 2 groups I'm looking at. 1 for women, 2 for men. I click continue, and now I move my thirst tone punishment scale into the test variables box. Let's see, I guess I missed that. There it is. Thirststone punishment, test variable options. No options here. Just click continue. OK. SPSS generates the output. So it just gives me, again, it reports the means to me for women and for men. So notice that there's very little difference. The standard deviations are fairly close to one another. So I don't have a lot of concern that the variances are, that the variability between the two groups are different. So the first thing I need to look at when I go to interpret, so I had a one-tailed test, and the one-tailed test suggested that men were more punitive than women. So the first thing I need to do is check direction. I have direction. Men are slightly more punitive than women, so since I have that direction, I proceed to assess the one-tailed test. And so the first thing I need to do is determine which t-test I'm going to use. One where equal variances are assumed, or one where equal variances are not assumed. So in this instance, I look at the probability value for the Levine's test, which determines the null hypothesis. And the null hypothesis here is that the variances are equal. So because this value, 0.299, is above 0.05, I use these top row of values. If this were below 0.05, I would use the bottom row, but that's not the case. Because this is above 0.05, I'm going to have equal variances assumed and use that top row. So I'm going to scroll over. So here's my obtained t-value, negative 0.307, and here's my probability level. So notice it's called significance two-tailed, but I actually have a one-tailed hypothesis, so I need to cut this 0.759 in half. And when I do that, even the halved value here is above 0.05. So the value of 0.3795 is the one-tailed probability level, and even that's above 0.05. So in this instance, I'm going to accept the null hypothesis that there is no difference between men and women in level of punitiveness, and reject that research hypothesis. So my one-tailed test didn't work out in my favor here because I accept the null hypothesis because this is above 0.05.